Certain alkaline earth metals are used in firework displays and produce colorful, vibrant lights when ignited. On a smaller scale, the flame test lab allows a visual representation of the characteristic flame colors these metals emit. The three metals we will use in our flame test are calcium, strontium, and barium. The materials that we will use for the flame tests are the flame test chemical solutions, 3 200 milliliter beakers, wooden sticks for soaking into the solutions, a Bunsen burner, and a flint lighter. To prepare for the flame tests, we soak the wooden sticks in the chemical solutions for about an hour so that the metal ions absorb into the wooden sticks. Before we go into the flame tests, we will quickly review the chemistry behind the colors that these metals emit when ignited. Let's take calcium for example. Calcium has 20 electrons, and 2 of them are valence electrons that are located in the 4th energy level. This diagram represents the calcium atom in its ground state, before any heat is added to the atom. When energy is added to this atom, whether through a spark, flame, or electrical current, a valence electron of the metal moves from its ground state to its excited state. This means that one of the electrons has jumped to a higher energy level. In this diagram, one of the valence electrons jumped from the 4th energy level to the 5th energy level. When this electron eventually returns to the ground state, it releases energy in the form of a wavelength of light. Each metal has its characteristic emission spectrum or range of wavelengths of lights that it emits, allowing metals to emit certain colors when put into a flame.
As you can see, the first metal that we are performing the flame test on is strontium, which emits a vibrant red color. All the colors that the metals emit in the flame test are part of the visible light portion of the electromagnetic spectrum. Wavelengths in the visible light portion are within 400 to 800 nanometers. The red color that the strontium emits has a wavelength between 620 and 780 nanometers.
The next metal that we will perform the flame test on is calcium. Calcium emits an orange-colored flame. The orange color produced has a wavelength of 585 to 620 nanometers. The last metal is barium. Although the color of the flame is hard to see, barium emits a green-colored light. The color green has a wavelength of 490 to 570 nanometers. Although we did not test magnesium, which is another alkaline earth metal, this metal produces a white-colored flame. Here we decided to experiment by combining metals in the flame test. This is a combination of calcium and strontium, which is a mix between orange and red. The other combinations that we tried were not very successful because barium did not produce a strong green color.